This video will give you a quick review of all the things that you have learned all throughout the year in Algebra 1. Please be patient and review and listen very carefully to make sure that you will be ready to take your Algebra 1 STAAR EOC. Function notation. For example, we're given a function y is equal to 2x plus 4. If you want to write this as a function notation, you can just easily write this as the function with an input of x is equal to 2x plus 4. So in other words, we can simply say that y is just equal to f of x. So y is just known as your f of x. So if you're being asked what is the value of f of 3, that would simply mean that your input is a 3. Therefore, you are going to substitute 3 into your x to your given function. So it'll be 2 times, that's the x, so you plug in a 3 plus 4. 2 times 3 is 6 plus 4, which would give you a 10. Therefore, f of 3 is equal to 10. So what is a function? A relation is a function if each value of x is only assigned to one value of y. In other words, x values are not repeated. Again, x values should not be repeated. So let's look at this first example. So focus on the x values. We have a 1, a 2, a 3, and a 4. Are any of those numbers repeated? Nope. So therefore, this is obviously a function. Now let's look at the second example. Again, focus on the x. A, and these are not numbers. It is okay to have variables in there. So we have A, B, C, B. Oops. What did you notice? B is repeated. So therefore, this is not a function. So how would you identify a function given a mapping? First of all, we need to understand what is a mapping. A mapping is a simple representation wherein all your values of x are mapped to your values of y, in which sometimes, of course, they would write y as your f of x. To avoid confusion, I would really suggest for you to take time to write all your coordinates. So for example here, 7 is mapped with negative 21, 9 is mapped with negative 3, 11 is mapped with negative 121, and 45 is mapped with negative 121. So then, try to notice your x values. Do you notice any repeats in the x values? Nope. So therefore, this mapping is indeed a function. Now let's look at the second map. Again, take time to always write your coordinates. 2 mapped with 20, 2 mapped with 5, 4 mapped with 10, 6 mapped with 25, and 8 mapped with 15. So again, let's check our x values. Oops, 2 is repeated right there. So therefore, this mapping is not a function. If we're given a graph, we can simply use the vertical line test to check if the given graph is a function. So how do you use the vertical line test? You simply drop a vertical line, and if it hits your graph only at one point, then it is a function. So here, if I'll drop a vertical line, and regardless where I dropped it, it will only hit it once. Therefore, this is also a function. Now notice this third example. If I'll drop a vertical line right here, I would hit it in 3 points. So whenever I hit it with 2 or more points, that graph is not a function. So moving on to domain and range. Domain is the set of x values, while range is the set of y values. So looking at this example, let's label which ones are x's and which ones are y values. So this ones are x, y, x, y, x, y, x, y, x, y. So then therefore, our domain would be -4, 8, -7, -4, and -9, while our range will be -4, 9, 0, 3, and there's another 0, but you don't need to write that again. So let's check if this set of points is actually a function. What is the definition of a function? We need to make sure that none of the x values are repeated. But let's check this out. -4 is repeated down here. -4. So therefore, this set is not a function. If we're asked to find the domain and range of points on a graph, we simply need to label and name where the points are located. So for example, this point is located on -1, -2, -3, -4, -5, -5 on the x, and 0 on the y. This point is located -2 and +1. This point is located 0 and -1, 2, 3, 4, 5. -5 on the y. This point is located at +2 and -3. And then this point is located on 1, 2, 3, +3, 1, 2, 3, 4, and +4. So then again, by definition, domain is just the set of the x values. So these numbers are your domains, while these numbers are your range. Just make sure that you're able to, just like what I did, try to circle the points to make sure that you have already named all the points and you don't miss any coordinate points. So let's find domain and range from a continuous data. Let's try to figure out the domain first. So again, domain focused on the x-axis. So if you are to trace your graph from here, you would notice that, oops, your graph starts right here. Trace it until where it stops. Your graph stops right here. But you are to choose the numbers that are on the x-axis. So then your domain would be x, -5. But notice that this endpoint right here is open. And these numbers right here are greater than -5. So x must be bigger than -5. And then right here on the other side, you have the 4. These numbers right here are less than the 4. But then again, notice the endpoint, it's shaded. So 4 must be included. So now let's move on to the range. So range is a set of the y values. So now we're going to switch our attention and focus on the y-axis instead. Now you're going to trace from the bottom of the y-axis and see where your graph starts. Notice that you start at -2. Then you go up further and you end up at +3. So the way we write that, of course, it's the y from -2 all the way to +3. Now, to write the inequality properly, compare the numbers that are in here. These ones are y's. Which one's bigger, -2 or y? Well, y is bigger. And notice that that is an open endpoint. So we just leave it like that. Now, if you look at the 3 up here, which one is bigger? These numbers or the 3? The 3 is bigger. And since the endpoint is shaded, what did I tell you? More shading, more work. That means it has to have the equal sign. Okay, let's do another one. So let's do domain again. So domain, we focus our attention on the x-axis. And where does your graph start? Right here, which is at 0. Where does it end? Right here at 7. So how would we write that? So x, this is our domain, x must be from 0 all the way to 7. And x is greater than, notice that it's shaded, or equal to 0, and x is less than or equal to 7. Take note that you always read from the variable. So you read this as x greater than 0 and x less than 7. Okay, now the range. Let's switch gears. So the range, we need to, again, highlight your y-axis and check where your graph starts from the very bottom. So you trace here from the very bottom, you would notice that your graph starts right here at -2, all the way to the highest point at 4. So how would you write that? Range is y from -2 to +4. Y is greater than -2 and less than or equal to 4. Notice that I put the equal sign in the bottom even though it is not shaded right here or shaded right here, but because you knew that it touched that point, so it can be equal to -2 and +4. So again, let's start with domain. Highlight your x. A lot of misconception that the majority of you does is that you think that the domain are these points. No, these are the x-intercept. Remember, domain is kind of like how wide is your graph. So if you trace your graph from here, would you really be able to make a point right here or to stop it right here? No, because of the arrows, you know that it would still go as wide as it can be. And so on this other side, it would still go as wide as it can be. So pretty much it'll cover your x values from -infinity to the positive infinity. So then our domain can be written as all real numbers. That means all the values of x is covered with your graph. So let's try to check the range of the same graph. So range is, again, you're going to focus on the y-axis. So it's kind of like trying to check how tall can your graph be. So starting from the bottom, trace where your graph starts, and you would realize and notice that it starts right here at -1. But then you would notice that it would never stop here. It would not stop there, right? Because there are arrow points. So that means it would continuously go up. So it would go up continuously all the way to positive infinity. And a lot of you would right away write all real numbers. But notice here in the bottom of the y, would it go to the negative infinity? It's not. It stops at where? At -1. So how will we write our range then? It's just y must be greater than or equal to -1. Independent and dependent variables. Please try to memorize this sentence because this would really help you. The blank causes the blank to change. And our first blank would simply be our independent variable, and our second blank is our dependent variable. So in other words, it's just ID. So here is an example. The most important thing here is for you to really understand what the problem or what the topic is about and be able to summarize the concept of the problem into this sentence. The blank causes the blank to change. So it says the entire high school marching band is going on a field trip. According to school district policy, the number of students on the trip determines how many parent chaperones are required to go along. So if you really think about it, how could we summarize this? What changes and what causes that to change? So if you look at it, you would notice that it says here that the number of students will cause the number of parent chaperones to change. So then the number of students causes the number of parent chaperones to change. So therefore, which one is your independent? It's always ID. So your independent variable would be the number of students, and then your dependent variable are the number of parent chaperones. Here's another example. Tim, a food blogger, receives payment from an advertiser each month. The more site visitors he has, the more he earns. So again, think, what changes here? What does not stay the same? So you would notice that the payment he receives would always change. And what causes that to change? The more site visitors he has, the more he earns. So then, the number of site visitors causes his earnings to change. And so therefore, this one is always ID. So the independent variable would be the number of site visitors, while the dependent variable is his earnings. To summarize all of the previous slides, I really want you to remember this picture or remember this clue and write it somewhere in your test so you will be reminded at all times. So this is just a shortcut or a reference for all that we have discussed earlier. So X and Y. Remember this. Doctor, ID, HV. Again, Doctor, ID, HV. What does this mean? That means this one's the domain, this one's the range, this one's the independent variable, and this one's the dependent variable. The X is always your horizontal axis, and your V is your vertical axis.